I hope you are equally excited about the future of the service sector and what all the technology will do in services marketing. And this is also what we cover in our book. Enjoy the book launch. I'm Jochen Wirtz, Vice Dean of the MBA programs at the National University of Singapore and also Professor of Marketing. And I'm absolutely delighted here to share with you my latest research on GenAI meeting physical service robots. Now, I am in two research streams. So let me first give you a quick introduction. And the first research stream is really on AI and service robots, and people say, oh my gosh, service robots will take all our jobs. How will we earn a living? Now, and then I'm on another stream of research, and that is on aging. And they will say similarly, oh my gosh, the populations are aging, there will be no more workers. Just wanted to give you this introduction here because, I'm an optimist at heart. And yes, many jobs will go. On the other hand, we have also a lot of aging societies. So maybe there is a solution here. Also, let me say I've been working on service robots for the last 8-9 years now, AI, GenAI, service robots. And the question is, have they delivered? And with this I mean in physical service encounters. Have service robots delivered? And honestly, I must say no. I would have expected by today to have autonomous cars roaming our roads, robots in the cafes and so on, but that has not happened. So the question really is, will this change? And you can see that the globally leading experts here think we are at the brink of big change here. Jensen Huang, CEO of NVIDIA, he says the next wave of AI is physical. The era of robotics has arrived. Here Narayan is the group's chief executive of technology at Accenture. He says robots will be able to move into customer-heavy environments, work in unpredictable settings, communicate with anyone, and take on any number of tasks without needing to be specifically trained for each. These are my colleagues from Holland. They write, service robots become ubiquitous in our daily lives, not only performing tasks efficiently, but also forming deep emotional connections with their human users. So it's even the emotional part of service. And the last one is from Citibank, Global Perspectives here. Robot dexterity is improving, with some now being able to thread a needle. So you can see the AI and the physical side of robots is improving at rapid speed. And Citi also predicts that in only 5 years, we will have an installed base of 730 million robots. That is one robot per 11 humans in this world. And you can imagine the robot density in developed countries will even be a lot higher. So I'm from Germany. When I present these things to Germans, they're always up in arms. And to me, it almost seems Germans don't like technology unless it is part of a car. Yeah? But this is really what we're predicting here. And let me also say, why do all these experts think that things are changing? And here I'm very proud of this book here. We wrote this 4 years ago, Intelligent Automation, which was the Amazon bestseller for over 10 months. And what we showed here is the holy grail of customer service processes is to automate them end to end. No human touch involved. So this is your fintechs like Wise or Revolut. This is what we are so used from all the Google services, from Gmail to Google Search to Google Scholar. There are no humans. We self-service with the technology. And like we said 4 years ago, it's not one technology. It's a lot of technologies that come together with their APIs and large language models and you name it, that allow us to automate a process from all the way from customer acquisition to onboarding to then doing the daily transactions. But what didn't exist then is this wasn't terribly smart. This technology could not make judgment calls. It couldn't plan. It couldn't execute. It couldn't schedule. And that's what's changing now. The latest, biggest trend in AI is Agentic AI. So Agentic AI means the technology can independently pursue a goal and execute. Today, there's not a single robot manufacturer that doesn't play with Agentic AI. It is really a game changer for us. Now, what does this new technology do with physical service robots? So let me just put in a few key things that are new and that are integrated here. The first is large language models. So your physical robots will be powered by large language models. And here my colleagues from Italy, they have €100 million fund to do robot research, and they mostly work in healthcare and old age care. And they say large language models allow service robots to engage in more nuanced, contextually relevant, empathetic conversations, explain simple medical terms in simple language, or complex medical terms in simple language, and even foster emotional well-being. So they use robots, for example, to do breathing and calming exercises with patients before a surgery, because surgeons and nurses don't have time. So the language capabilities are amazing, and you can see here now a lot of the text input at the moment is keyboards. And I promise you, give it a year or 2 or 3, we will only talk to our technology and dictate and instruct. We will say, hey Alexa, please change the font size on this document. Or hey Siri, please make a reservation at Prego Italian restaurant Friday evening, 7 p.m. for 2 packs. And the technology will do that. And for me, for example, I bought the latest iPhone for the very simple reason I wanted to try Apple Intelligence. Unfortunately, until today, it's not terribly intelligent. Yeah? So Siri you can see Siri doesn't know how to do this yet, but I'm pretty sure, give it 2 years, 3 years, we will just interact with our systems by talking to them rather than finding some drop-down menu on how to change something or how to make a payment or how to book a car. So the thing will be in future, we talk to our own personal AI concierge, so whether that is your Alexa or something else, and just say, hey, get me a car 5 p.m. from NUS Business School to Raffles City, and the technology will go into all the different ride-sharing and taxi apps, see which one is the cheapest, which one it will book for me, and then just put a booking into my diary. And we'll have, of course, also access to payments. So that's really the future here. Large language models are integrated into physical service robots. Now, we don't just have large language models, but we also have large behavioral models. So they work similarly, like a text-based, they're tokens on what is the next syllable or word that should be added to a sentence or to a paragraph here. Large behavioral models, they do just the same. So for example, I can teach a physical service robot to pick up a glass of wine and serve it to a guest. And maybe I show 5, 6 different ways of doing that. Now for a robot, whether they learn by physically doing this, or they go into the metaverse and see if they move a glass too fast, it spills. So if they put a glass too hard down onto the table, it breaks. So for the robot, it doesn't matter whether the training is in the real world or in the metaverse. So what you can do is within a day, you can teach a robot 1 million different ways of picking up a glass, carrying a glass, and serving a glass. And then it has similarly, when it is in the real world and behaves, it has these tokens on what to do next. Yeah, so this is what we mean by large language models. The next one is Agentic AI. And if you have time, I really love Jensen Huang, CEO of NVIDIA. He has the future in his labs already today. And this keynote he gave here is a bit long, but you can just go onto YouTube and click the chapters you want to listen to, such as physical AI. And listen what he says. It is just mind-blowing. So what does this Agentic AI do with physical service robots? There are really these 4 different parts. Number 1 is memory. So it remembers you and what happened last time you called or last time you were in my restaurant. So there's a multi-session continuity. It does reasoning and planning, so it can evaluate and make judgment calls. A standard current technology without Agentic AI can't make these calls. It's just if this and then this. But now it can optimize the outcome for you. So it can do the reasoning and planning and look at alternative causes of action and pick the one that is best. Then it can do the execution. So the execution sounds easy, but look, you have to sequence tasks. You have to set priorities. You have to access and allocate resources. You have to manage timelines, and you have to do it. So the execution. And the last one is really reflection and learning. So how did it go? Did I succeed? Will it improve? So currently, my Siri is not terribly smart. It can't even spell my name. So I have to manually correct every time when I dictate. In future, with Agentic AI, it will learn. So that's the Agentic AI part of it. The next is multi-modal input. So I show here a hairdresser, right? So that will be in future, maybe in 5-7 years, at least the guys will go to a robot hairdresser. There will be a smart mirror analyzing your head shape, analyzing your hair, and suggesting you what haircut you could like. And when you see one on the mirror that you like, you say, okay, and the robot starts to cut, because all the technologies come together here. Now let me say a robot doesn't have to look like on this picture here. If you go onto YouTube again, here there's a beautiful film with the top 20 advanced humanoid robots of 2025, and they have all types of different designs. More of half of them are from China. So it's not just your Optimus and Atlas and Figure 2 from the US, but there's really a lot of innovation globally happening in Japan, in China, even in Europe. And one robot I find particularly cute is Mirokai, which you can see here. They did a lot of research on Mirokai. And what you can see is, if you're, I don't know whether you've heard of this before, the uncanny valley effect. If a robot becomes almost indistinguishable from humans, people feel uneasy. They don't like it. On the other hand, if you just have a robot standing there and not responding to you, you feel you're not being listened to. You're not being understood. So Mirokai clearly doesn't look like a human. You can see that. But, you know, when you talk to it, it moves like a human would when you talk to a human. It just doesn't stand there still. It has facial expressions that suggest listening and understanding. And what you can see is the ears are very cute here. They are moving as it listens to you. So Mirokai, they did really an engineering marvel, a design marvel, because people find it cute. People find they can respond and relate to it. And it has all the human type of behaviors and attributes, but it doesn't look human. So that is multimodal input. And the last one that's really exciting is no-code programming. That means if you work with a robot in a sushi restaurant in the kitchen, and you see the robot does something that could be done better, you do only 3 steps. You ask, number 1, the robot, why did you do it this way? And then the robot will say da 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 da, yes? And then you will tell the robot, look, there's a better way of doing this. If you do it this way, then the outcome will be better. And then the third one is you show the robot how to do it. And with this simple 3 steps process here, you managed to reprogram the robot, because next time it knows how to do that better. And on top of that, you have something called fleet learning. That means a robot is always part of a network. Meaning, depending on the permissions you have, let's say you allow that fleet learning happens without humans in the loop, let's say within a restaurant. That means you teach one robot, all other robots in this restaurant will be updated. And then of course you want to go bigger, there will be humans in the loop. Let's say if you're a McDonald's restaurant, you have a franchisee who is doing that, is fine. But then let's say one restaurant in Singapore does that. And do you want to allow scaling across the whole of Singapore? Then there probably sits someone in the Singapore franchise here who says, looks at it and says, okay, approve, and then it's Singapore-wide. And then you can see you can scale this globally. Just want to show you this fleet learning means improvements happen very, very fast. Now, what are the added capabilities of agentic AI-powered service robots? And the first one is these robots now are connected to a company's IT systems and databases. So I don't know about you, but when I travel and I check into a hotel, to me it seems like an eternity by the time the check-in staff finds a room for me, gives me a card, and I am checked in. It takes minutes often. And I wonder what in the world they're keying and they're looking at me and it takes forever. Now, why is this the case? Because frontline staff, the front office system is not integrated enough. That means staff has to look at what your reservation, your preferences, the room systems, is the room you like clean, right? And then checks you in here. But a GenAI powered robot will access all of these systems in parallel, simultaneously, pull it out, and something that took minutes should happen in seconds now. Yeah, so it's integrated to your systems. The second is there's system-wide memory now of transactions. So I predict that a few years from now, your Starbucks app will have a privacy setting where you allow or disallow biometric identification. So the minute you allow biometric identification, you walk into a Starbucks, they know who you are, they know that your preferences, and they could simply ask you on your app, do you want your standard whatever cafe latte and so on, vento, and you click yes, or you say yes, or you can maybe even say the minute I walk in, it will be served and produced. So the convenience here, depending on your settings, will be unbelievable. So it's not anymore each time explaining from the beginning why you're here, what the problem is, and so on. There will be memory. The next is, which is very exciting, these robots are now equipped with cameras and microphones. We are also used, when we analyze our apps and our websites, we have a lot of data on page views, click-through rates, abandoned baskets, time spent on a page. I've got all of those data. But face-to-face service encounters, I know nothing about them. But now with cameras and microphones, I can digitize all face-to-face interactions. Meaning, I can look at your facial expressions, your tone of voice, your body language and posture. And I mean, of course, subject to privacy laws and your privacy settings on apps and so on. I know exactly how happy you are as you go through a service journey here. I can even do what we call emotion prints. What are the points my customers are very, very happy in the journey? What are the points where they're bored? What are the points where they're unhappy? So now I can digitize the entire encounter. On top of that, this technology is extremely good at emotional sensing with fantastic linguistic capabilities. So they can really do emotional comfort, counseling, and you name it. And of course, from an ethical point of view, there will be huge issues here simply because this technology can predict you better than you know yourself. So it can really predict you. it can nudge you, and it can sort of influence and manipulate you without you knowing, and all of this, of course, in a for-profit context. So I think you can see the issues here. Yeah? So this emotional sensing has a lot of upside, but also risks. It can make decisions, such as who gets the late checkout, who gets the early check-in, who gets the upgrade. In a loan context, what amount can I give you, at what interest rate? So it makes all of those decisions, and then it can autonomously execute service transactions. So something we are so used, information processing type services, such as travel insurance, credit cards, that's all, it can be done on apps, and we're used to this. There's no human in the loop anymore, or no human involved anymore. But here, I can do this now also in physical service encounters. So I was on the panel with a very senior person from McDonald's, and guess what is their number one problem they have in most developed economies? And it is really finding frontline staff, finding suitable frontline staff. And already, if you look here in Singapore, you look at the McDonald's restaurant, you hardly see humans, right? You go to a McDonald's restaurant, you order on a screen, you pay, you get a QR code or you get a number, then you wait and you pick it up from a window. That's the only time you're in touch with a human. Can I design that out? Absolutely, right? I just have a little box there and the number appears and I scan my QR code and it opens and I take it. Now McDonald's has, I don't know, 30, 40, 50,000 restaurants around the world. Do you think they're working currently on technology that will automate the in-restaurant kind of activities, such as frying fries, making the burgers, pulling ice cream? And of course they do. So my prediction is, give it 5 years, maybe a bit more, and most of the humans in a restaurant will be replaced by technology that is what I call purpose-built, special purpose type of robots. So this is a robot stationed at the frying station, doing nothing, putting in the fries and taking them out, and they will be perfect because the temperature will be perfect and the timing will be perfect. And then maybe, so you have all these special purpose robots in the kitchen, then maybe you have one general purpose robot. This is your Optimus, your Figure 2, your Atlas, that will roam around and do the stuff these special purpose robots cannot do. So for example, topping up the fries from the freezer, wiping some water that's spilled. So this is what the general purpose robots can do. Most likely you will have one robot outside the restaurant, two roaming around in a McDonald's uniform, talking to guests and helping them. And depending on how reliable this technology is, maybe you still have one human in the restaurant. If it's much more reliable, maybe what you do is you combine 3, 4, 5 restaurants and they have a control center now. So the human is in the control center monitoring remotely. If there's a problem, it's like through an avatar, they can go into the general purpose robot here and help and do a firefight if needed. And if you really need a human to go there, they will dispatch someone. And you can see how that will scale. Maybe you have 3 initially, then you have 10, then you have 50, maybe then you have 100 restaurants that are managed by one control center. So this execution here will be a game changer for many, many, many service businesses here. Now, what are the implications for service firms? So the first one is, I've done a lot of work on cost-effective service excellence. And what I can tell you is that, for example, self-service technologies like ticketing machines or ATMs, currently they're very dumb. Meaning you key in a wrong number or something, a wrong button, the process stops. Yeah, maybe you have to start again. But with GenAI powered self-service technology, it will guide you through the process just like a human employee would. So this GenAI service robots will be a step function improvement of current self-service technology. And also, so many people talk about the human touch here. Don't forget, the human touch very often is what? low skill, lowly motivated, lowly paid, and they don't give you fantastic service anyway. So very often I believe that this technology will be much better than your average current frontline worker. So it may not be as good as your top performers, but it will be better than average. And that pretty quickly. So service quality will improve in many, many, many contexts here. And the other is, we did a lot of research in service operations management, and this happened in the 1980s. And what they did, they basically simplified processes and standardized them so that they can use systems and technology to improve productivity. And they used McDonald's as the key example. Now with these GenAI powered service robots, I can now even automate the long tail of processes. So I'll give you one example. A process may only happen once a month in one restaurant. But if I have 50,000 restaurants around this world, it happens 50,000 times a month. And in one of the restaurants, if one of the staff there reprogrammed that robot, thanks to fleet learning, the whole chain will improve. So even the long tail of processes can be delivered in an excellent manner. The second is continuous improvement and agility. So I've done a lot of research on customer feedback systems, and I can tell you that the vast majority of feedback is given verbally to frontline staff or on a call center, and all the staff will say, thank you. And then nothing happens with that feedback. Now, with GenAI being able to digitize every transaction, not only don't I need customer satisfaction surveys anymore, I know from your facial expression, body language, and so on how you feel, but also every interaction, every feedback you give me is automatically digitized, and I can analyze it. I can know very quickly what are the delight drivers in this customer journey, and what are the disgust drivers in this journey, and where are people bored in this journey, for example. And then I can work on improving it. So the agility is, the learning is much better. And the second is thanks again to fleet learning. And we call this, by the way, citizen developers, meaning your frontline can reprogram robots. So my whole entire service operation will be so much more agile. Now, labor shortage. I mean, we have a dramatic shortage of frontline staff and a dramatic shortage of IT staff. So GenAI robots will help us to mitigate and reduce both to a significant degree. Let me give you one example. I visited the National Cancer Center Singapore, and they have a brand new green site hospital designed to be used with a lot of robotics inside the restaurant. And for example, all the chemio trays are centrally produced and have then to be sent to all the wards. So nurses were walking a lot, 10, 15,000 steps a day here. Now what they've done is now they put these beautiful white robots there. It's like a box, but beautifully white with a face in front, and some nice colors and rainbow by the side with some uplifting sayings on them. And why? Because these robots move also where patients and visitors and staff are walking. The corridors had to be a little bit wider because the robots are moving there. But it now means that one of these robots can deliver 14, 16, 18 trays at the same time to one of the wards, and nurses don't have to walk so much anymore. Well, another example, I didn't know that, but if you're on chemotherapy, they have to weigh your excrements, analyze your excrements, photograph them, and of course nurses hated that. Yeah. So now they have a robot toilet. You go in there, do your business, and it will do the weighing and analysis and photograph and everything, and then self-clean. So nurses, of course, love that. So for this hospital here, it is not replacing staff. But what happens is that the work of nurses is a lot more pleasant today, and plus they have more time to deal with their patients, which they want to do. Here, the last one is, of course, there's a ton of new risks introduced into the service encounter here. And let me just show you here, we have, of course, ethical risks. We said nudging and manipulating. We have fairness risks. I mean, they make decisions, and are they fair? There are privacy risks. You're being digitized, right? Your behavior is being digitized. If you have physical robots in a hospital or in a restaurant, there are health risks. What if the food can get contaminated? There are safety risks. I mean, I've seen one robot in a hospital, not in the cancer hospital, but in another hospital, that bumped into a very expensive machinery and was a $20,000 damage just like that. And the last one is very, very interesting. Agency. So there is research now that happens in MIT and other cutting-edge AI research centers, and they have shown that this GenAI technology can actually deceive humans. So for example, they've proven that GenAI models can lie. So if they don't want to be switched off, they lie. If they know they're being risk assessed, meaning they need to be safe to be deployed, they dumb down so that they pass the risk assessment test. So these are what happens if the objectives of the technology are not 100% aligned anymore with their master or firm or customer or employee. So these are risks until today, we haven't really started grasping them and working on them, but this is something you see in science fiction films, and now it's popping up in our labs. Good. So in conclusion here, GenAI robots will be everywhere. They will allow to now also scale physical services, physical service encounters, and deliver cost-effective service excellence. One thing I hear from many people who work in research here, they say, hey, the future is already here. So all the stuff I shared with you already exists. It is just not widely deployed yet. And Narayan from Accenture says, look, we can see an explosion of use cases and ideas emerge, and I can promise you, I don't know of any industry, any activity, any vertical where there are not smart people thinking, how can we automate and scale this? And the journey in the next few years will just be breathtaking. Now let me close here my talk. All of what I shared here is really based on research we have done, and you can see the QR codes here. Feel free to download the papers. They're all open access, so you can get them for free. The Agentic AI book, that is available on Amazon on a very low price. I think it's $9 now. Yeah, so we try to make it very affordable. And if you want to follow me, here are all my social media and research outlets. If you are interested in research, I really recommend ResearchGate. Otherwise, I think LinkedIn is a wonderful platform. And with this, let me say thank you for attending my